Hello and welcome back to Cracking the Cryptic. Now, I had already recorded a video today, but we've had a number of quite late queries today, but one of them seems to take precedence, and that is that Maria in Mexico has lost her dog. And obviously she is very stressed about it, having panic attacks, and I'm not surprised. So as remote as the chance is that anybody is living near Morelia, Mexico, and finding a basset hound that has lost its way, please get in touch with us at least, or you can see Maria's details there, and that might be the way to deal with it. And look, there's Bueno Recompensa there, so it would be well worth doing. Do help out if you're somewhere in Mexico and you could help. That would be kind. But I know, we know, it's a Simon's just tweeted about it. Okay. Well, even he knows it's a complete long shot, but we just thought we would at least put the plea out there. Now, there were a couple of other queries. Ryan asked if what was the way to the catalogue, and he'd like a shout out if possible. Well, I've mentioned your name, Ryan. Now, there is a catalogue of all our videos, and it is available, and it is on the links under the video. It's one of the descriptions there. If you look for the word catalogue in the descriptions, it will take you to, I think there's a tiny URL link that will take you to the masterful catalogue maintained by Keelbean Hacker of all our videos from when we began. Now, that brings me to the third point, which was somebody called Jeremiah got in touch and said some of our early videos weren't filmed with our software that we're now using, and that's certainly true. Or rather, they weren't given links to play the puzzles in the current software. Now, there are two types. Back in the really early days, there wasn't software to play these puzzles in. We occasionally told people they could play them in the New York Times or the Times app, and they were generally classics. You could probably put them into Sudoku Pad and play them there. It wouldn't take long. So Jeremiah was actually volunteering to go back to the past and correct all the links. But it gets a lot easier when we got to Sam's time sometime in early 2019, maybe April, May, sometime around there. That's incredible. That is nearly 3 years ago. It doesn't feel that long to me. But anyway, Sam created the first version of the web app that we now use. And I think, if I'm right about this, all you need to do is change the... if you are wanting to play our older puzzles from between, I'm guessing, April to... well, maybe for most of a year in 2019... if you want to do them in the new software, Sven's current version, all you have to do is change the first bit between slashes from crackingthecryptic.web.app to app.crackingthecryptic.com. And the simpler way of doing that is if you take the 10-character code at the end of the old links and just apply it to a puzzle from the new links in your browser, that will take you to the puzzle you're trying to play in the current tech. So it's quite easily done, and thanks very much, as always, to Sam and Sven for all their works on that. So all of these links are under the videos. You can find those kind of codes and the CTC catalog. You can find our merchandise, links to all our apps, which will soon be fully updated, and then we will start launching more, which is great, I think. And what else? You can find the ways to Patreon, where we will be launching a new hunt, a very approachable one, at the start of March, and to Discord. But the first link, as always, is to today's puzzle. So I hope this isn't going to take all that long, because I'm starting this very late. The video I had done for today will be postponed till tomorrow, so apologies if I've said anything like the date or anything mad like that, but that will be coming out tomorrow. And today, and that gives me a chance to go out with my wife on her birthday tomorrow. That's good. But today I'm going to be trying Sauron's Demise by Xeon Risk. Now that is a bit nerve-wracking. Xeon Risk has not traditionally been easy, has often been brilliant, but has not been an easy constructor. So we will see how this goes. And there is a chance I will have to just give up and go with today's video. Maybe I'll carry on going and put this up tomorrow, but that would be bad in terms of the appeal to look for the lost dog, who we would much rather find today. So let's hope I can get this done within, well, certainly within an hour. I'm going to guess about 35 minutes for a Xeon Risk puzzle, but we shall see. Now, the rules are fairly straightforward. Normal Sudoku rules: numbers along an arrow must sum to the number shown in the attached circle, and numbers along indicated diagonals, which can include repeats, must sum to the given total. So those 7 digits will add up to 37, for instance. Only 2 of those little killer clues, but do give it a try if you fancy it on the link under the video. I'm going to start now. Let's get cracking. Let's get cracking. Well, that, and that, and that. No, not that. That is what I meant. They all have to be 6, 7, 8, 9 because given the positions of the digits on their arrows, they all have to be different. And they have to be at least 1, 2, 3. So that's not very useful. Right, there are 5 arrow cells in box 8. Yes, and another one on those arrows here. Okay, so the maximum value of these 2 circles in the attached circles, is 17, being 9 and 8. Now, what's the minimum value on these arrows? Well, this one, well, these 5 cells could be 1, 2, 3, 4, 5. That's already 15, and another 1 at least there is 16. So there's only 1 degree of freedom here. And that means that can be that 1 minimum or 2. These are either 1, 2, 3, 4, are either 1, 2, 3, 4, 5 or 1, 2, 3, 4, 6 if they use up the degree of freedom. And these 2 are either 9 and 8 or 9 and 7 if they use up the degree of freedom. So there's definitely a 9 there. So now this circle doesn't have a 9 on because there's a 9 in the box. And that means there's a 1 on its arrow because numbers up to 8 with 3 digits have to include a 1 in their sum. So if that was a 1, the 1 would be here, but we could still get a 1 on this arrow. Oh, I thought I was getting somewhere, but it doesn't really resolve anything, does it? I don't even think it's very interesting that there's a 9 in one of these 2 cells. It doesn't do much for the column where there aren't any other circles. What about these? What about those 3? I don't know, but I was just highlighting those 6 arrow cells, and I note that they're on the Pfister-Maffei ring. I could go through the theorem that says that this group of 16 cells have to be exactly the same digits as this group of 16 cells, but I'm not actually sure how that's going to help at the moment. Now, that group does include 3 circles, which are slightly big, whereas these are probably all slightly small, but even amongst those there could be a 6 overlap. So, okay, the maximum for these, because the circles are in the same column, they have to be different. So the maximum for these is 17 again. But that's not so helpful this time. I mean, the minimum for those is 10, so the maximum for these is 7. That's not really very interesting. 17. They can't be the same set of 3 digits because that one can't be one of those 3, but okay. I wonder if there's some sort of, there's so little to go on. I don't think these 37 and 29 little killer clues are any use at the moment at all. They don't go through enough arrow cells to make the fact that they're a fraction above the average number 5 per cell useful. I'm wondering about set theory, and Pfister-Maffei's ring is one example of that. There's so little to go on, that's why I'm wondering about set theory. Also, there are some straight lines which warp into the circles, and we've seen that before. So there's one there, there's one there, there's one there, and there's another here. This is interesting too. What if we took row 9 and column 9? Now, each row and column is a set of the digits 1 to 9. So that's 2 sets of the digits 1 to 9 if we allow for the fact that we have to double count one of them. So those 17 cells include 2 sets of the digits 1 to 9, although not that one. But I want to compare them with this box, which is 1 set of the digits 1 to 9 by Sudoku rules. So let's make that box green. And now if I eliminate purple and green cells, okay, what I'm doing is I'm comparing 2 sets in purple of the digits 1 to 9 with 1 set in green of the digits 1 to 9. Now anything I can eliminate comes out of both of those groups. So if I eliminate those, which are 1 purple and 1 green in each, if I eliminate this, it brings it down to a single purple. But that purple is the same value as these greens. So I could eliminate them both now from this. Then I could eliminate this green and these purples. Now I've got no greens left, but I had greens plus another set of 1 to 9 equals purples. So now these remaining purples are a set of 1 to 9. And I am left wondering how that helps me at all. I suppose I could translate this purple into those two. No, I think this is nonsense. Okay, let's go back to basics. Okay, let's highlight all the rows and columns which have the full 3 strings that I mentioned first, and all in the same colour. Let's try it this way. Row 3 and row 9, column 3 and column 9. Well, that has a certain symmetry as well. So they're purple. That is 4 sets of the digits 1 to 9, although there are 4 overlaps where we have to count twice in those positions. Now, let's compare it with, finding what to compare it with. This is the hard thing in set, but look, there's this as well, which goes into this box. And that goes into this, yes, this box is important. I'm going to make that green. This one definitely green. This one looks good, green. And let's do box 1 as well. Right, this might work. I don't know, this might work. Okay, what I've highlighted now is 4 sets of 1 to 9 in purple. Remember that blue cells are double counted. And 4 sets of 1 to 9 in green. Now I'm going to subtract, like an algebraic equation, I'm going to subtract the same digits from each side. And I'm going to do that wherever I get 1 green and 1 purple, in a cell. So all of these can come out of it. Some of these cells might come back into it. Now, to get rid of these, I get rid of 1 green and 1 purple, and I'm left with a single purple, which is good in those cases. Now, I should have the same number of cells highlighted. I've got 16 in green, and yeah, it's like a slightly warped Pfister-Maffei ring, actually. But I think I've proved that these purple cells have to be exactly the same set as the green. And this is what set theory is all about, is finding these sets. And now we're going to see why this is useful, and it clearly is. Because now forget the exact set of digits. We'll look at totals, because we can start eliminating totals. those three purples add up to the same as that green, because that's what the arrow means. So let's get rid of them. Those three purples add up to that green, because that's what the arrow means. Those three greens add up to that purple, because that's what that arrow means. These three purple and that green, these three purple and that green. And now the totals of these tiny little numbers of cells that we've got left are the same. But then there's a really tiny number of purple cells. Oh, in fact, let's get rid of the purple and the two greens there as well. Yes, we can keep getting rid of purples, and we get rid of purple and the two greens there. And look, now our purple set, which is that single cell that looked so innocent at the start, has the same value as our green set, which is 5 different cells. So if that's a 9 maximum, these could be 1, 1, and 1, 2, 3 is 8. There's a degree of freedom, but I think that goes away. So let's just fill it in at the moment with that degree of freedom. These at the minimum would be 1. They've got 1 degree of freedom to 2. That is 9 at the max, has 1 degree of freedom. This is 1, 2, 3 or 1, 2, 4. Now that's really interesting because it definitely involves 1 and 2. So whatever that is has to be in these 3 cells and can't be in those 2. So whatever that is has to be there. And this is brilliant. The degree of freedom is going to go away. Because if that's a 1, not using the degree of freedom, 1 is there and that can't be 1. So because of this little shape, these have to be different. And there goes the degree of freedom. That is a 1-2 pair. That's not 2 1s. So the degree of freedom has gone. That is now a 1, 2, 3 set. This is definitely a 9 and is our first digit. Oh, this is genius. I mean, you can see how the magic aspect of Sauron's demise is invoked here. That cell has to be the same as that one, because not purple flash, let's give it a red flash. And therefore it's not 3, it's 1 or 2. This cell is again in this group, but it can't be one of those 2. So those 2 are the same. Orange is hardly a big enough contrast. Let's make it green and grey. And that again can't be 3. So that's a 1-2 pair, and this is 3. And there's our second number in the grid, not on an arrow, not on a circle, not on a little killer clue, just in a corner. In fact, that's 3 in the corner, definitely losing its religion up there. And there we go. Well, I mean, that's the start. Now, this puzzle may not get easier, but that is absolutely mental. Oh, look, this is the other 1 or 2. So we can colour that green-grey because it's the same as these. It's in the same column as the red one. That can't be red. So there's another red one somewhere here. And another grey one somewhere here. There's a degree of symmetry about that. I don't think either of those positions mean that one of these has to be 2, 3, 4 and can't have a 1 on it, which was what I was rather suspecting. Now, come on. How can we use this further? Yes, this cell sees 1 and 2. So it's at least 3, but this can't be more than 8, and that's getting interesting. This is at least 3. It can go up to 5, I reckon. And then here, and it's not 1, so we can take that pencil mark out. Here, we've got to have the 1 on this pair. I don't know what colour it is. If that's a 3, this could be as much as 1 and 4. It's either 1, 2, 1, 3, or 1, 4. It's definitely a 1 in this area. Come on, what can we do? What can we do? That can't be a 1 or a 2, but that doesn't feel very exciting. Ah, neither of these can be a 1 or a 2. Because in the column, that cell sees both colours, and in the row, that cell sees both colours. Is that useful? Yeah, well, I mean, they've got to... they could be 4 and 5 to avoid having a 3 on. If they've got a 3 on, it's here. So that could be a 6. Otherwise, either of them could be 4 or 5. I think those are the candidates. And this has to be at least 7. And it would be 7 if that was 3 and that was 4. Now, if that was 3, that would force this higher. And that feels like it has some impact. Maybe it doesn't. This can't be a 9 now because of the 9 we've got. Oh, there is a 9 in one of these two cells. There's a 9 here and a 9 there. So one of those two is a 9. Oh, hang on. Let's have a look at this. Right, this has now got 3 on it. That's a 1, 2 of different persuasions. So this has got 3 on it. What's the maximum going on this? This one can't be a 9. I'm just going to write the maximums, the maxima in the corners. 8, 6, I reckon there, if it was surrounded by a 1, 2 pair to make 9. This one can be 9. This, again 6. And this one, I suppose, 9. Now, what we get up to there, it looks a bit much now. 3 in those two, plus 9 is 12, 18, 27, 33, 41. 4 degrees of freedom. So that is quite high. These can't both be 6s because they would make both of these 9s. And actually, there may even be more than that going on because they would also force 1, 2s in all of those positions, and that wouldn't work. Oh, in fact, this can't be 1 or 2 or 3. It's in the same box. Oh, well, things have just got very interesting. That is 4, 5, or 6. The maximum this can be now is no longer 6. It's not even 4, I don't think. How could that be a 4? Yes, you could make 5 in these cells, but that would involve another 4. So I think the maximum there is 3. And now we have got something very different going on. 3 there, 12, 15, 24, 38. 1 degree of freedom. That is much more useful. So let us fill in the candidates now. 9 and 8. 3 and 2. It can't even be a 1 now. 9 and 8. 6 and 5, and that's big. I shall come back to that. 8 or 7. Right. If this is 6 or 5, it needs a 1 on the arrow to keep it down to 9. It's either 1, 2 or 1, 3 on the remaining cells. And this, what's this going to be? The absolute maximum is 3, with that being 4 and 2, but that would make this 9. Now, there might be some interplay still between these digits. Since they can't both be 9s, does that restrict? What happens if this is a 3 and a 6? That's a 6. This is 2, 1. That becomes a 5 or a 4. Yeah, if this is a 6, this is definitely 9. Now that can't be more than 8. So then it would have to be 4, 1, 3 with 6, 1, 2. And that does work, which is irritating. We're very close to cracking through on this diagonal. Now, something else I can say, one of those has to be a 9 because we can only take 1 degree of freedom from this diagonal anywhere. And that means that there are a bunch of cells that can't have a 9 in, like the ones I've just highlighted, because at least one of those two I did highlight there and there has to have a 9, and they automatically rule these out. But that doesn't quite get anything done. I don't think I've managed to think hard enough about 3 and 6, and I don't know why that is. Let me ponder this a fraction more. Maybe there's an interaction with something else in the puzzle, but we're definitely onto something here. Right, here we go. Grey, grey. There's only one 1 here. obviously. But because grey has been used there in column 2 and there in column 1, the one in column 3 is in this box. So the one of these cells that is a 1 is the grey one. And that can't be here because there's a grey already in the row. So this is the green grey and is a 1. Oh, no, 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 hang on. No, I'm talking absolute tripe. Because I was imagining these were 1s, but they could be 2s. And then that could be a 2, and that could be a 1, and that all works. So, okay, I take back what I just said. It was not true. I mean, it might be that that's green and grey, but... Okay, no, simple. Well, not simple, but something. Where is green and grey? That question still remains. It can't be there. It can't be there because that's 5 or 6. So it is here. And this cell can't be a 3. That's what we can conclude. It's not everything, because it doesn't prove it's a 1, which would have been nice. Now, there's another grey somewhere here. Ah. Now, there has to be a red. Why don't I just make these fully grey, so I stop having to call them green and grey, and these red. And just get rid of the green, because we don't really, I don't think we're going to use the set theory anymore. So we'll get rid of those colours. Now, we've got grey and red 1 and 2s. Where is the red 1 and 2 here? Well, it's in one of these cells. Ah, I was going to say, where's the grey one? And it can't be in the same 2, but it can. It can still be here. So if this is red and grey, then we're going to get grey here, which is no surprise because that will give us a grey here. Okay, I need to find something else. I need to get some other restriction or work on this diagonal better. If that's a 3, maybe the question is, does one of these have to be maximum? Right, if these were both... No. Does one of them have to be minimum? That's the question. If that's a 3 and that's a 6, then we get a 9 here, and we get, oh, I've done this before, we get 1, 2, we get 1 there, 4 there. Now, is there a problem with that? 4, 1, 6, 2 would be this sequence. This would be 4, 1, 3, which would mean if this was a 3, that it wouldn't be red. So that would be red, a 1. This would be a 3. Grey would be in one of those 2 cells and one of those 2. Oh, come on. Come on, I'm not getting this. Sorry if you are seeing what to do here while I'm stumbling around looking for more clues. Don't think the 29's any use. 17, 23, nah, it's not. 3, 1, 2. If that was a 3, to keep that down to 7, there'd definitely be a 3 here. It doesn't, oh, this can't be a 6 anymore because that's at least 4. That's barely interesting. I suppose this can't be 6 or 7. That is now 8 or 9. Ah, this can't be a 7 because it could be 4, 1, 2, and then a 6 here. Ah, this is a 7, 8, 9 triple now. And this can't be 1, 2, 3 because they've been used up in the box. 789 triple. What's that going to do? It doesn't really do much, does it? What about this? Have I got a 789 triple? Can I rule that out of being 1, 2, 3? Not really. Oh, that would make a 1, 2, 3 triple here. Oh, come on. We're getting closer now. 789 triple. Now, is there some problem? If that's an 8-9 pair. Now, for these to be at their maximum, this has to be an 8-9 pair. If we're not going to take one off those two, for them to be at their maximum, 3 and 6, that 6 forces this to be 9, that 3 forces this to be 8. So then that would be an 8-9 pair, and this would be 7. Also, we'd have an 8-9 pair here, and this would be 6 or 7. Needing a 1 and a 2 in these cells, which would have to be grey here. Oh, right. No, that's fine. Grey here is fine. It makes one of these a 3. One of them would be red and the other would be a 3. But that's, in fact, we're working on if that's 3 and that's 6. I'm just trying to prove that maybe there's a reason that can't be the case, because that would take the degree of freedom off the other 3 cells, which feels like it would help. So if this was 3 and 6, this would be 8 and 9. That would be 9. Come on, there's something here. 1. And that would be red. I'm clutching at straws there. If that was 3 and 6, we'd have 9, 8, 9. That would be 7 and 6. That would be grey 1 or 2. This would be 4 and red 1 or 2. Grey and red would both be down here. I can't see it. Okay, this can't be more than... Now, I didn't do this before because this could have been as little as 4 originally, but now this cell is at least 3. Now, I'm not going above 5 because this can't go above 8. So even with a 1-2 pair here, that will get to 6. Now, these could add up to, what's the biggest here? 8. Smallest here, 3. These could add up to 5. So they're from 1, 2, 3, 4. Now I've got a 3, 4, 5 triple in the column and a 1, 2 pair. That can't be 9. It's 6, 7 or 8. This one, again, 6, 7, 8 or 9. Is this getting anywhere? I don't think it is. This 3, 4, 5 triple, I mean, it's a strange one. It exists, but why is it not doing anything helpful for me? It's just being willfully mean and recalcitrant. These add up to 5 or less, so one of them is a 1 or 2, or maybe both. It'd be great to prove it couldn't be both, but I can't see a way of doing that. Oh, I'm really stuck. I mean, I thought getting the set breakthrough was going to do this puzzle, and instead, absolutely not. Let's just check this again. 8. Ah, 9, 8 there. So actually, 9, 6 is the maximum. 15 and 6 is 21. For 8 minimum there doesn't do anything. Okay, no, that 29's no use. So it's all about this. It must be all about this. If I can prove that somewhere we lose the degree of freedom on one of these cells, and I'm sure there must be something in this. If that's a 3 and that's a 6, we get 9, 8. Nine, 6 or 7 there. We'd get 7 here. I haven't really focused on that yet. I don't see how it helps, but this felt interesting, but it's not quite a quadruple. Okay, this can't. Oh, if this is a, yeah, this can still be 7, can it? 2, 4, 1, 6 there, and 1, 2. I think it can. Maybe this is a definite 9, 8 pair. I can't lose the degree of freedom off both, so I can't take this down to the 214 minimum and this down to the 125 minimum, because that would put 5 and 2 here and make the 37 impossible. So this can't be 7 and 8. So one of them is 9, but actually I knew that anyway. It could be 7 and 9. I knew that anyway because I've got a 7, 8, 9 triple in column 2, so one of them is 9. Well, my planned timing for this video is shot to bits now, but never mind. It is interesting though, isn't it? This is 6. Now, these two cells must be at least 1 and 3. One can be red, but the other can't be grey. So that's at least 4 then. And this could be grey. And that could keep this down to 6. Oh, just one thing away from getting through. Now, whatever this is, 5 or 6, has to be in one of those cells. Because it can't be up here. Now, how about this being 3, which seems quite unlikely? That would make this 9, 3, 5, 1. That would be a 9. This would have to be a 4 then, again. Almost anything I speculate about makes this a 4. Maybe that's what to do. If this was a 5, you could have 5, 1, 2 at the minimum for 8. 1, 6, 2 at the minimum for 9. And that even works the other way around. This can still be a 6 with 6, 1, 2 and 5, 1, 2 there. That's so maddening. Why can't I see what's going on? Grey. Grey can't be in any of those cells because of the position of grey here. But that leaves all of those possible for grey, including especially that where it probably is. So that didn't help at all. Now that can't be 1 or 2 or 3. Okay, I mean, it doesn't feel very powerful, but that's at least 4. That makes this at a maximum 5, I suppose. This at a minimum is 5 as well, because it could be 4 and 1. And that's almost all the arrows fully pencil marked, maybe apart from that. I'm just not seeing what's going on here, am I? 6 and 3 there. But still, 3 and 4 making 7 seems possible. But, oh, okay, that would... Right, these are 3, 4 and 5. Now they push up. One of them's a 5. If that's a 5, this is 9. If that's a 5, this is 8. If that's a 5, this is 8. So one of these is at their max, at least. And maybe more of them. What does that do? And the other one can have a 4 on and be at its mid-range, and only the third can be at its minimum. Come on. One of them's a 5. What good is that? Now, if that's a 5, that's a 4, that's a 9. Now we get 9 here as a result, which puts 8 there. That definitely puts 7 here, which makes this 2, 1, 4. This has to be... I thought I worked out this had to be 9 in that case, but that's not true. So if that's a 5, we get 4, 9, 9, 8, 7. We get 2, 1, 4 along there. One of those 2 1s has to be grey, so that would become grey. Ah. That would be really useful. If that's a grey-red pair, and therefore that's grey, then this trio can't include grey and would either have to be 1, 3, 4 or 2, 3, 4, and this would be 8 or 9, which would form a pair. So if that's grey, this is 7, which actually supports it being grey. Because that would be a grey-red pair. Being 1, 2. Right, that's possible. Come on, think of something here. I feel like I'm almost on the verge of this, but that could be absolute nonsense. For this to be grey means that would be a 9-8 pair with a 7 here. I don't know. 9, 8, 7, 6. One of these must be a 6. Doesn't feel strongly exciting. Might be something to do with this 3, 4, 5 and the fact that one of them has to be a 5. So if that was a 5, we'd know about red and grey in this box. That would make this 8. Which would make that 9. That just doesn't seem exciting enough. Ah, if that was 9, so if this was 5 and 4, that would be 9. Now I've just realised why that is a bit more interesting. Sorry, if this was 5, That would be 4. This would be 9. Now that would be 8, and that would take away the degree of freedom. So if this was where the 5 was, with a 4 there, this would be 9. That would be 8. Now these have to be at their max, the 3 and 6. So that is 3, 1, 4, but that would make that 8. Oh no, the max is 3, 2, 4 to make that 9. 6. Ah, but the 6 would make that 9. Right, let's take this slowly. If that was a 5, making this a maximum 9, that becomes 8, takes the degree of freedom off the diagonal. That means this is 6 and that's 3. And this is 8, remember. Now that being 6 makes this 9. And that makes this see a 9 and an 8 and have to be a 7, which it can't be with a 3 on it. So that is not a 5. It's not the maximum. Either 5 is here or here in this column. And this can't be, it hasn't affected that. By goodness though, that's complicated just to rule a 5 out of that cell. Maybe it's simpler to rule a 5 out of one of the others. If that's a 5, let's pick on this. Then we've got grey, red, 1, 2 here. Then red's going to be on here. Grey is going to be up here somewhere. If that's a 5, we've got an 8 here. We get 9 and 7 here. This has to be a 6, 8 pair. That's not interesting. What else? What else? Want the 1, 2 here? Ah! So frustrating. Red. What are you doing to me, grey and red? Or am I just getting fixated on you when you are useless? That is quite possible. This can't be 1 or 2 or 9 or 3, but that's so uninteresting, it's painful. Actually, watching this video is painful. 3 and 6. 3 and 6. Something is wrong with you, 3 and 6. What is wrong with 3 and 6? 9, 7. Oh, I see. That has taken so long and it's probably been painfully obvious. Okay, this doesn't necessarily do everything, but it does a lot. I can see what it does. Right. If those don't use up the degree of freedom on the diagonal, if they are 3 and 6, that becomes 8 at a minimum, that becomes 9 at a minimum, that becomes 7 at the minimum, and that's on the diagonal too and would use the degree of freedom. So one of those 3 uses the degree of freedom and these 2 don't, and they're both 9s, and that gets us twice the number of cells I had before. Now, this is not a 9, this is 9 now. So this isn't 9, which actually it never was, because but never mind. This is not 9. So this has become 8. This can't be 6 anymore. 8 or 7 max there. Now come on, give me something else. 9 there, 9 there. We get a 9 in one of these 2. 9 there and 9 there. We've got a 9 there as well. 9 in one of these 2. I need this to give me something. 9 in row 1 is there. Not somewhere I was expecting help from. So that can't be a 9, and this can't be a 5 or a 4 actually now. Ah, that's become 1, 2 or 3. That's almost enough to be red. I don't think I can go further than that from that 9 alone. So the positions I've got for 9 are now, oh bother, there and there. This hasn't, oh, this can't be 9 anymore. Ah. Now this can't be 6 anymore. But this can still just be 3. This could be 3, 1, 4 making 8, or 2, 1, 4 making 7. But what about this? This can't be 3 anymore. So it's either red or grey. So this can still, does it have to be 1? Yes, it can't be 2 anymore because that would be 3 and 4 making 9. So that is 1. I'd better do something. The trouble is this could still be where red is, so that doesn't have to be red. Oh, come on. So these could still be max, 3 and 6. Ah, if they were, that would be red, and that would be red. If they were both max. Surely this has freed something up. Don't think it has. Let's look at this row. We need another 2 or 3, which can't be there and has to be here. That's interesting. Now there's an 8 there. Or, well, this can't be 9, so there has to be a 1 on this arrow. So it's in one of those cells. And it is red, because 1 and 2 are always red or grey. But I don't know which one is red. Oh, and grey can't be in those cells. So grey's up here in the corner. In fact, it's there. That's the only place that can be grey because of that. Oh no, it could be there. Bother. Bother, 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 bother. Could be a 2 and be there. So red and grey. Well, grey is in one of those 2 cells. Red is somewhere down here. But I mean, I suppose this could be... Oh, come on now. If that's a 5, these are 1 and 2. That's not... Oh no, that is possible. Red there, grey there, red there. Then that would have to be red as well. Oh, it's teetering on the brink of impossibility, but I cannot get this home. Oh, it's getting awful now. Feeling this. 9 there. 1, 2, 3. That could be 7 or 8 if that was the 6. Okay, 6, 7, 8 maximum there and there. These are from... They can't have a 5 in. Oh, they could. That could be a 2, and then this could be 1, 5. So they're from 1, 2, 3, 4, or 5. Which means the third 6, 7, or 8 in this box is in one of these 2 cells, which is also the third in the column. And that kind of means this can only be 1, 2, 3, 4, 5 as well, but it just doesn't feel like it helps. Oh, red is in one of those 2 cells, and so is 1. And grey can't be in those cells, so grey is not 1, grey is 2. Oh my goodness, how long does it take to see the bleeding obvious? Grey is 2, red is 1. Does this help at all? Red is in one of those 2, it's not down here. But grey is 2. Now, come on. That's not a 2 now. Red is 1. This isn't a 2 either. This can't be a 3 because that would add up to 10. So that is a 1 and is red. And there is a red 1 down here somewhere. Quite likely to be there, but it doesn't have to be. Although if that was a 1, this would be 2, 3, 4 with a 9 here. Then this would have to be 1, 5, making an 8 here. So it's difficult for that to be red, but not impossible. Oh, that's a 2. That's taken away the degree of freedom that let one of these be a 6 or one of these be a 7. So that is now a 9-8 pair. And that's not 8. So this isn't 5. And now the 5 in this column has been fixed. Yes. Wow, so I can do the 1 and 2 and I can go crazy colouring these things now. Red, blue is grey. None of these are a 2. That's not a 1. One of these is a 1. Come on, this is it now. These must have a 1 in, mustn't they? No, they could be 3 and 4. Come on, this is progress. Surely we're here now. That's 6 or 7. This can't be a 1-3 pair because that would still need a 3. This is a 1-2 pair for sure. So that's a 1-2 pair. We can uncolour that. One of these is red and that can't, it's got to be here. This one is grey. Oh, and we know the numbers. Red is 1, grey is 2. So that is, there is a 2 down here. That's not a 1 anymore. So that's 3 or 5, 3, 4 or 5. 5. This can't be 3, 4 or 5. Can't be, oh it could, this could still be a 3, 4 pair. But that can't be 5. Come on, piece by piece, that can't be 2. We've got an 8-9 pair, a 1-2. We need a 1 in one of those two. We need a 2 in one of those two. Where are our other 2s? Somewhere there and somewhere there. 2s. Those are the areas left for 2s. Oh, and that's not a 1 now. So that is... what does... Oh, that doesn't really do anything else. This could still be up to 5. Can't be 2 anymore. Oh, it can't be 5. We've had a 5 in the box, but this can still add up from anywhere from 6 to 8. Oh, that's a 2-3 pair. I've known that for ages, but I don't know which is grey. 5, 2, 1, 9. Seven or 8 needs a 3 on it. They can't both be 4s, so that's a 3. And that makes that a 3 by Sudoku. There we go. 4, 8. That becomes a 9, and we do get a 6. Oh, well, ever since I got that as a 5, it's been staring at that. Oh, my scanning is shot to pieces by the stress this video has caused me. That's become a 7. Right, let's just get focused and get real now. 2, 6, 1, 7. That's not a 9. That's a 9. That's not a 9, I say. That's a 9. Oh, that's on the diagonal. Let's just check this diagonal. 13, 22, 28, 35, 37. Right. 13 there. Now, the maximum this can be is 5. That would be 18. The maximum here is 7. That would be 22. The maximum here is 8, and that would be 30. And there's only 9, 14, 18, 25. Oh, my maths is way off. 33. So there's still 4 degrees of freedom there, which is very annoying. That is, in fact, 3, 4, or 5, because it sees everything else. This 4 degrees of freedom, I suppose it could come down to 4, not 3, and this could come down to 4 as well. So that was really totally unhelpful at the moment. But we'll come back to that, I feel. That can't be 4. 2, 8, 7, 9, 2, 9, 1. Come on. 1, 2, 5, 9. 7. Oh, 4, 1, 3. That's become a 2, which is colourful. That means this is a 2 by Sudoku. Ah, well, at least I knew it couldn't be there on the diagonal. So doing that nonsense work on the diagonal actually turned out to be useful, incredibly. So it gets us the last 2 in the grid there. Still don't know about this pair, this X-wing on 1s. I mean, I'm prepared to bet that'll be the one in the end, but can't actually do that. 9, 8 pair, so those don't have an 8, and that's a 7, 6 pair. 2, 9, 1. Oh my goodness, I still haven't got this stuff sorted out. 1, 3, 4, 5. Oh, that can't be a 2 anymore, of course. 3, 4 there would make that 1, 5, but 5, 1 there would make that 3, 4. So they seem to go in pairs, 5, 1 and 3, 4. That's definitely true. In which case, since 1 is in one of those cells, 5 is in one of those and can't be there. Which probably doesn't do anything, but frankly, I'm taking anything I can find at the moment. 6 or 7 there. Oh, that's become a 3, so that's a 4. Scanning again. That can't be a 7 now. 71. We've got 3, 6, and 5 to place in this box. 3, 9, 2, 7. 8's up in one of those cells in the column, so that's not 8, which I could have known from that total as well. Now that's a 6, 7 pair. So these are from 4, 5, and 8. 2, 9, 3. In fact, that's not 8 because there's an 8 in that row already. That's 8 in the corner. Ah, and I had 8. Why did I have 8 in a corner mark there? Yes, 8 in this box can't be in any of those cells, so it's here. And that is in an arrow. So we get a 5 here and a 4 here. We get a 3 here. That sorts out the rest of box 3. And now, finally, I think we might actually be approaching a solution. This is now 5, 5, 2, 9, 1, 3, 8. So we've got 4, 6, and 7 across the middle of the top. That's a triple. This is 3, 5, and 8. And if 3 is in one of those, this becomes a 1, which was exactly what I expected, but couldn't prove. Let's just colour it right. There we go. Now, 5 and 8 with a 1 here. This is either 4 or 7. And I don't know which. But we've got 3, 5, 8 here. So, in fact, 7 in the box has to be there. So that's what it is. Oh, what am I doing now? I'm doing colours instead of numbers. Right, there we go. 7, 8 in the circle. 5, 3 pair. 6, 4 pair here. Oh, that 8 has made that a 9 and that an 8, so now we know that's a 5. This is a 3, 4 pair. We know the order. Might have just finished all the arrows there. No, look, I have if I fill that in. This has become a 3. And we are just finishing off now, weirdly, after all that strain and stress. 3 or 4 there. That can't be 3. We've got what? We've got 4, 5, and 7. Well, that's 4 or 5 as well. So this becomes a 3. That's where 7 is in the row. That must be a 6 with a 5 here. This is an 8. It's the last thing we need in the box. 3 and 6. 4 and 8 here. This has turned into a very long video, but very rewarding. What an excellent puzzle. And what a meal I've made of it, I imagine. 9. That. Oh, that's a 6. Just, it's naked. Hang on. This is terrible. Oh, I was going to say I've got this awful deadly pattern, but I'd forgotten the old diagonal. 18. These have to add up to 11, so they are 7 and 4. Whew! That fixes the pattern. It fixes the puzzle. And it fixes my admiration for Xeon Risk, who is an absolutely epic creator of Sudoku. So there we go. That is hard. I mean, finding that. And I thought it was about those two being max, but it was about those 3. That wicked cell there. That is Sauron's demise. Yeah, this Sauron feels quite demised by that. But anyway, thank you so much for watching. Don't forget the catalogue, and if you are in Mexico, look for the dog. Thank you very much. Lovely to see you on the channel as always, and hope to see you again soon. Bye for now.